Welcome back to geometry. We are talking about chapter 4, section 3, triangles. See, I told you, there's a lot to say about triangles. Now, last time we learned that we can prove triangles congruent, meaning they're the same size and shape, if you prove all the sides are the same and all the angles are the same. Turns out you actually don't have to do that much proving. You can, here I have two triangles that are the same and all the sides are the same. Excuse me, if we were in class, I would make you take 3 pencils of 3 different sizes and try to make a different triangle than the one you can make, and you can't. The sides dictate the angles. So if the sides are the same, the angles have to be the same. So one thing you can do, if you just prove all the sides the same, you have proven the two triangles congruent. It's called side, side, side. And it's so handy and dandy, and we love it so much, it has its own little abbreviation that we use. We never write out side, side, side. We just put SSS. It doesn't mean a snake hissing. It's side, side, side. Now the other one we're going to talk about today is called side, angle, side. It turns out that if you prove two sides are the same and the angle between them, you will have proven that the triangles are the same. And the reason why, get your hand out like this. Okay, and here are 2 sides of a triangle, and here's the third one. If you move this angle and change it, it dictates how long this side is. So if it's a bigger angle, it's a longer side. If it's a shorter angle, it's a smaller side. But the angle controls the side. So if the angles are the same, the sides are the same across from them. Do your hands like this and think about it. It'll make sense. Okay? So this one is called side, angle, side. It has to be between them. It can't be first. And one of the things I show kids is, if you did it the other way, if it was angle, side, side, that spells a bad word that we can't write on the board in public school, because we would just giggle the whole period and nobody could learn any math. So good thing that one doesn't work anyway. So it can't be ass, it's got to be side, angle, side. The angle has to be between them. See, now you're going to remember it. Okay, so here's a proof of these two triangles. We have these 2 sides are the same and those 2 sides are the same. Can we prove the 2 triangles are the same? And if so, is it by side, side, side or side, angle, side? Well, we can. So we wrote down our givens, and now we can say that angle 1 equals angle 2, why? Vertical angles. Dun-dun-dun. So we can say 1 equals 2 by vertical angles. And then we can say triangle ADE is the same as DCE by side, angle, side. Side, angle, side. And see, you don't have to write it all out. All right, here are 2 triangles stuck together. They look like some superhero symbol. Can we prove these 2 are the same? And if so, is it by side, side, side or side, angle, side? Well, we know 2 sides are the same. How about the angles between them? Do we know those are the same? No. What about that side? What does that symbol mean? The reflexive property. Line PR equals line PR. So we could write a proof. We could write down our givens, and then we could say line PR equals line PR by the reflexive property, and then we can say this triangle equals that triangle or is congruent by side, side, side. Okay? How about this one? Can we say these 2 triangles are congruent? Yes, we can. How we can do it is we have these 2 sides together, and do you think it's side, side, side or side, angle, side? Well, we got angle here. We know if this angle's a right angle, that angle's a right angle by the right angles theorem that we learned, that all right angles are congruent, and if lines are perpendicular, they form 4 right angles. So we have 2 sides, these 2 sides the same, these 2 angles the same. Where's our other side? Because it looks like it's going to be side, angle, side. It's that one. That line by reflexive property is congruent to itself. So when I told you reflexive, you thought I was dumb. You thought, why in the world would you say A equals A? This is why. We're going to prove triangles are congruent. Okay, here's another thing that's just kind of interesting. That nature obeys these laws. Right now my boys have this old console they were given, hand-me-down, and it's gotten wobbledy. So like they've got their gaming stuff in it and it's going flipping and flopping, and they think that their gaming system is no longer safe because the thing wobbles over to the side. Turns out if they will nail a board across the back of it, it will force it to become straight. And the reason why is because these two lines are parallel. They're cut by a transversal. So alternate interior angles are congruent. And this side here, this board that they would nail across, would be congruent to itself. You would have two congruent triangles, and the angles and the sides would have to be fixed. So this stabilizes like a door or anything, or a frame, anything that wobbles. If you cut it with a transversal and nail a diagonal board on it, it will not do that anymore. And I told them, and they got someone gave them a different one. They're like, no, we're just going to use the new one. But I'm like, but you can use geometry, science. Okay, so the last thing in this chapter is, well, they've got a graph and they have two triangles, and are these two triangles congruent? Well, we can check it and see if their sides are the same. On this side of this triangle, it goes from 0 to 5, so that side is 5. Over here, it goes from 1 to 6, so that side is 5. So those two sides are the same. This one goes from -7, that should be, to -5. No, to +5. It's going from -7.5 to -4.5. So this side is 3. And this one's going from 5 to 2, so this side is 3. We know two sides are the same. But for us to know these two triangles are the same, we need to know if that third side is the same. And one way we can figure it out, we could figure it out with the Pythagorean theorem. But another way to figure it out is to use the distance formula. Remember, we learned this, it's from the Pythagorean theorem, and it's distance equals x2 minus x1 squared plus y2 minus y1 squared. And remember, how you know which is which is the x that's closer to this side, the one that is less is x1. The x that's over here, that's more, is x2, and the one goes with the y goes with the x. They have to stay together. But actually with the distance formula, it doesn't matter because distances can't be negative. I don't say it's 2 miles from my house to the library and -2 miles from the library to my house. Does that make sense? But in other things it does matter, like slope. So it's good to know how to do that. I had a hard time learning that because I had a concussion, I've been in a bad horse accident, but you can understand it. All right, so there are calculator programs that are fun for your TI-84 graphing calculator where you can do the distance program. And if you've had me for math, I've given them to you. So if you have, and you've got those programs, I want you to use those programs when you do your homework. But if not, how you put it in is, see, if we do BC, these are the ones, those are the twos. So you go x2 minus x1 squared plus y2 minus y1 squared. That's 3 squared plus 5 squared, which is 34. And then you square root it, and that doesn't end up as a nice number. So this length is the square root of 34. Then we do it again here. And these are our ones, those are our twos. So we do 6 minus 1 and 5 minus 2, square them. And it's also the square root of 34. So by side, 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 we know those two triangles are congruent. All right, math is great. See you next time.